We now want to talk about some schematic conventions. So first, circuits are typically drawn at right angles, so orthogonal, 0, 90, 180, 270, and so forth. Occasionally, you will see things that are drawn at 45. An example of that might be a 4-diode bridge rectifier circuit that might be drawn something like this. And so, as a whole, circuits will be drawn at right angles to each other, but sometimes 45 degrees is acceptable. Okay, signal flow is typically going from left to right. So in a simple schematic such as this source and this load, you might think of what's flowing as power. There's power coming from the source going to the load, and so power is moving from left to right, and the source is placed on the left side. The load is on the right. This schematic here is an audio amplifier stage, and if we look, it's hard to see here, but this is the audio input on the left, and we have speakers on the right. And so the signal, in this case, is flowing, the audio signal is flowing from the left to the right. I'll let you take a look at these other ones. I also talk about these in Lab 1, pre-lab. Okay, now we want to talk about signal or connecting wires. And so I want to point out that all continuously touching or connecting wires are all part of the same node. So you see up here, this is all part of the same node here. Okay, it wouldn't matter how long some wire traveled away. If there was a resistor over here and it connected back here, we would say all of this would be part of that one node. Additionally, sometimes to keep schematics from being cluttered, we'll use labels for nodes. And so, for instance, here you see that there is a wire goes so far and then it stops, but a little arrow signal symbol, and then VX. And so we're labeling that node VX. Further along in the schematic, there might be another place where a wire kind of comes out of thin air, and we've got to label VX. In this case, there's actually a connection between these two. And so keep that in mind. They're all part of the same node. Now, schematics use reference nodes. And typically the two types are ground nodes and then power supply nodes. So we'll talk about power supply nodes in a moment. There are multiple symbols used for grounds, and a circuit can have more than one ground. And that might be difficult to understand that at this point, but you can have separate grounds. If you've ever seen a transformer, the transformer has windings on one primary winding and a secondary winding, and those two windings could be connected to their own circuit. Each of those circuits could have their own ground. One ground might be a primary ground, the other one would be a secondary ground. In addition, there is a symbol for earth ground. So earth ground is a special type of ground. That means that literally there is a stake that is stuck into the ground, and so that node is at the same potential as earth ground. Recall that by labeling a reference node, you are essentially setting a reference level for all of the other node voltages in the circuit. It's kind of like defining sea level and then talking about the topography relative to sea level. So when we say that some point is 2,500 feet, elevation, we know that it's above sea level. Here's an example of a circuit that actually makes use of a ground symbol here. They're just using a simple straight line for ground, but notice all the places in this circuit where there are ground symbols. If they had not used these ground symbols, they would have had to run a wire around everywhere here, and it would have gotten really cluttered, and it would be, the schematic would be less clear. Just like we have ground reference symbols, we also have power supply symbols. So here are some power supply symbols: an arrow, a circle, another. Oh, something happened. These got messed up. Sometimes two. I don't know what happened there. Okay. Yeah, so these are different symbols, and you'll typically have something like +5 or +9, -10, or you'll have symbols like VCC, VEE, VDD, VSS. There's some history as to why those labels are called, or why those symbols are have those names, but you will see those commonly used for power supply rails. So here's an example of a circuit that uses power supply rails, and notice that we have 3 places here where there is a power supply symbol with VCC next to it. All of those points, everything connected to those 3 labels, or those 3 power supply symbols, are all on the same node. Okay, same is true for ground, and then the same is true for -VEE. Sometimes you might even see a schematic like this one here, where you just are shown some power supply symbol, and then you have a label VCC equal 5 volt. And nowhere else does it show VCC on this circuit, or certainly there's no place where that VCC is coming from, like say a voltage source or a battery elsewhere that actually says, oh, VCC. And that is shorthand to basically say, hey, for this circuit to work, you're going to have to provide 5 volts to this node, and we're not bothering to show you how you're going to get that, but just know that you've got to provide 5 volts.